Omniverse tools provide a friendly UI for editing USD files. But let's take a peek behind the curtain and take a look at the raw USD files. First though, my social media manager suggested I might get more likes if I included a cute puppy. So here is a cute puppy. Now, if this idea of yours gets me more likes than the other videos, I'm going to be very upset. So we've got our project here from the previous lesson, saved away on disk, and let's now have a look at looking at the underlying raw files. Now, a USD file can actually be stored in multiple formats. One format's called USDA, which is a text file format which can be edited by a text editor, and that's what we're going to look at the moment. But there are also other formats, particularly USDC, which is the crate or binary file format. Now, there is a .USDA and a .USD file extension, a .USDC file extension, I should say. But what you can just use is .USD and then have the file in either format. And the benefit of doing this is if you're referring from one file to another, you can just refer to a USD file, and then that file can either be the more efficient USDC file for the binary format, or if you're debugging, for example, you can just have it as a USDA file, which can make it easier to explore, easier to debug, and work out what's going on. Now, there is one other file format that I'll just briefly mention, which is USDZ or USDZ, depending on what part of the world you're from. And it's basically a zip file with no compression and no encoding, and it allows you to bundle up a number of files together. So you could have a USD file referring to some texture files, for example. Apple uses that format, for example, to have a single downloadable file for AR experiences. So I've navigated down to the USD file for this particular scene. If we right click and then select Edit from the menu, it'll open up your text editor. I've got Visual Studio Code here, and you might notice it's created a USDA file here. You can see from the file extension. So this is the textual version. This is actually a temporary file it creates. You can tell by its path. It's in a local temp directory on my Windows box. And if I make it, this is showing a textual representation of the actual model file. So I've just reorganized my windows to get them side by side so we can see them both at the same time. So in the USDA file, the very first line is always this magic line hash USDA 1.0, which is a version number. And that's how utilities can work out. So when it goes to read a USD file, if the first characters are hash USDA, it knows it's an ASCII file and to read it as such. I'm not actually sure it's ASCII. It may actually be UTF-8. I'm not exactly sure, to be honest. At the beginning of the file is a group in parenthesis. This group is what's called file level metadata. I'm not going to go into it too much, but it's got information about, we're going to talk about this in a later episode, about the default prim. It's got how many meters per unit. So it's got some metadata. It's relevant to the overall file. And so it's got some information in there. But what we're going to actually look at is focus on the actual prims in the file. So if you remember, over in the scene window here, we've got which is marked as a default prim, which is one called world. And here it is in the USDA file. It says def xform in double quotes world double quotes. And so this is defining that prim at the root. We've then got braces, and inside the braces are all the nested information. It's also got all the properties. We don't actually have any properties set on this xform node, so we can go into the nested group, which is the grove. If you remember, I moved some of these things around. I picked the whole grove and moved it, and what it's done then is it's stored this information about there's no change to rotation, it's all zeros, the scale is all ones, but the translate, which moves it around in the scene, has got some values there to move it. And then there's some other things talking about the order that these operations should be applied. So even though I've only changed one value, it is worth noting that it didn't only output a translate property, it actually output all three, and that's just what Omniverse is going to do. When you do anything, move, scale, or rotate, it just always sets all of the values. Okay, and then if we go back over to the stage window over here, we've got the three apple trees, and we had the first, the second, which is one I renamed. And so if we come over to the text representation, we've got a def, which is defining a new prim. We've got the prim name, but you notice it didn't put a type in this time. And the reason is because it's referring off to an external file. And it's going to get the prim type out of that file in effect. And the root will be almost certainly an X form, because that's how it turned into an X form here. So if we actually opened up that resource, we'd see that the first, the root element is actually an X form in that thing. Inside the this first apple, again, we've got positioning information. We've got the X form operations of rotate, scale, and translate. And it's just always going to pick a particular order to apply them in. And that's the full definition of the apple tree. It's actually referring off to the external file and then just moving it. The other apple tree, same sort of thing. It's referred off to the same external file again, and it's just got a different transform. If you actually look, the position is different than the previous one. And the same for the third, which I've put my own name onto it. Again, it's just in a different location. And so we've got the three transform nodes for the three apple trees. Now, it ends the braces to say, okay, that's the end of the world. And, oh, no, that's the end of the grove, sorry. And then underneath groves, we have, looking over in the stage window, we had looks, and it was a scope. And so here it says def, scope, looks. So again, inside the double quotes, we've got a name, and it goes through and then defines the materials, and it's got a whole lot of parameters that are defined based on the material type. So if you look up the material definition, you work out what sort of properties you should be setting for it. And then it just goes on. And in this particular example, it's got lots and lots of information about how to do all the painting of the grass, and lots of exciting, really, content in this file for sure. It goes on and on and on and on. So you get a bit of idea why it's all normally written out in binary format. It makes it a lot more efficient. Just at the end of the file is the sky. I mean, that represents the same as the sky down here, which is of the prim type of dome light, which is all this background information. So as you can see, it's pretty easy to get in and have a look at exactly what's going on. So the binary format contains exactly the same information. It's just in a more efficient binary representation, which makes it faster to load and for the machine to process. So what else can you do? Well, what I'm just going to do, I'm going to scroll back up, excuse me for a moment, and we're going to have a look at these three trees. So one of the useful things is if I come into this file and I delete that change. So what I've done is, I've deleted one of the trees. So now I've only got common apple and my second tree, and I save it. Over here in the stage window, the tree just disappears. If I come back into my file and undo and save that, the tree reappears. So I can make live edits in this text editor, and Omniverse Create will automatically refresh the scene to show me my changes. So that can be really useful for debugging purposes. I can get in there and I can sort of say, because this one I actually changed the rotation. Well, let's say I want to make it 190 degrees, and so the tree should rotate. Except I picked the wrong axis, so it's rotated it down into the ground. Clever. But it just gives you a bit of a chance to get in and have a look at the underlying files. And we're going to be using this feature in upcoming videos as well, because we can get in and look at the exact details of what's going on in USD underneath the covers. When you're finished, if you come back over into the content panel, into the content window, right click, and now instead of edit, there's a finish editing. And if you click that, what it does is it deletes the temporary file. If we come up over here to Visual Studio, it's showing that the file no longer exists. That's because we've cleaned it up. And it's always a good idea when you're finished to hit that finish editing just to clean up all those temporary files all over the place, and also so it's not watching for the file and trying to reapply the changes. So we can just go in and close that file off. So that's all I wanted to show this time. We'll get into a bit more about the details in upcoming videos, but it's a very useful ability to go in and edit the files and have a look at the raw USD files as human readable text. Okay, till next time.